5.1 Keeping things in proportion. Compare two quantities using ratios. A ratio is a comparison of two quantities. For example, according to research, every 77 people like Coke, 12 do not. We would say that ratio of those who like Coke and do not are 77 to 23. Ratios are typically written in two ways, a colon and as a fraction. Fractions are ratios, so we could write that 77 dot dot 23 or 77 over 23. From 1969 through 1977, 4 MLB teams made the playoffs each year, while 20 did not. Now 10 make the playoffs and 20 do not. Let's write the ratio of teams making the playoffs to the total number of teams in 1969 and today. We're going to write each ratio in fractional form, then reduce the fraction if you can. Then we're going to describe what those ratios tell us about how likely a given team is to make the playoffs now compared to the mid-1970s. Alright, let's pull out information. It told us that in 1969, 20 did not make it and 4 did. So what that means is that there's 24 teams and 4 made it. So if we want to make a ratio for teams that made it to the playoffs, we would put how many actually made it to the playoffs. That's 4. And we always put the total on the bottom. The total is always on the bottom because it's 4 out of how many. And that's total 24 teams. We can simplify this fraction because they're both even. So if we have 4 over 24, we can divide by 2. And that leaves us with 2 over 12. Because it's even again, we can divide by 2. So that leaves us with 1 over 6. So what that means is 1 over 6. So 1 out of 6 teams make it to the playoffs. Alright, now let's describe the ratios about today versus the 1970s. So now 10 teams make it when 20 don't. So now 10 teams make the playoffs and 20 do not. So that gives us a new total of 30. We have 30 teams now. So we want to figure out how many make it. So 10 make it out of 30. This one's easy to simplify. We just cancel out the zeros. So that leaves us with 1 over 3. So nowadays, 1 out of 3 teams make it to the playoffs. Back then, 1 out of 6 teams made it to the playoffs. Let's describe the value of using ratios to compare quantities rather than differences. A proportion is an equation that two ratios are equal. Understanding ratios can be really helpful in making sure that you have set up a proportion correctly. Based on a combination of worldwide surveys conducted from 2015 to 2017 for every 85 adults that would be happy to stay in the country they live in, 15 would prefer to immigrate to a different country. At the time, with the adult population of the world was 5 billion, based on these results, how many of those people were happy where they lived? So we could write the ratio based on the survey as want to stay over want to leave. So 85 wanted to stay, 15 wanted to leave. And we can compare that to the overall population. Do you notice on top we have want to stay? So on top we have want to stay. On the bottom we have want to leave. And on the bottom we can have total adults that we have. So you always want to match things. what we're talking about, you want left to right to match and top to bottom to match. Let's practice this. Monique plans to remove a tree from her backyard. She needs to know the height of the tree. Monique is 6 feet tall and determines that when her shadow is 9 feet long, the shadow of the tree is 45 feet long. How tall is the tree? So let's separate both of these shapes. We have a big triangle right here. And then we have a small triangle right here. So what we want always goes on top, no matter what. Because we're setting up a proportion, we know this is a proportion because we're comparing the height of something to the height of someone. So what we want always goes on top. We want to know how tall the tree is. That's the height of the tree. So do you notice on top, we already put tree. That means when we create our fractions, the tree has to be on top. So top and bottom, so left and right side, we also want them to match. On the left side, we're talking about height. So we want to compare the height of the tree to another height we have. We have the height of Monique. So on the top, we have tree. On the left side, we have height. So that means when we set up our fraction, tree needs to stay on top. Let's look at information we have. They give us the shadow of the tree. So tree is still on top. So now do you notice on the right side that's shadow? So on the top is tree. On the bottom, we labeled that Monique. So on the right side, we have shadow. On the left side, we have height. That means on the right side, we need to stick with the shadow. And we actually do have the shadow of Monique. So height of the tree, we don't know. It actually told us that it's x. So we have x over the height of Monique. We know Monique is 6 feet tall. It says it right here and up here. Now we need the shadow of the tree. The shadow of the tree is right here, and it also says it. The shadow is 45 feet. And that's going to be over the shadow of Monique. Her shadow is 9 feet long. It's also right here. Because this is a proportion, you can just multiply straight across, although there is an easier way. It's called cross multiplying. So if we cross multiply x times 9, that's 9x. 6 times 45, we get 270. We divide by 9 to get x by itself. So we get x is 30 feet. That means the tree is 30 feet long. We're going to solve problems using proportional reasoning. So this is actually a true story. My car has one of those touchscreen things for maps, music, and so forth, and you can upload your own picture to the background screen. The catch is the size of the picture has to be 800 pixels wide and 384 pixels high, or it gets stretched and looks goofy. You've done that, right? If you upload a profile picture, it looks all weird, so you have to like resize it. Actually, the picture doesn't have to be exactly those dimensions, it just has to have the same ratio of width to height. The most recent picture I chose to use as a background screen has a native width of 1164 pixels. To what height did I need to crop it? Alright, let's write out the given. We're given a lot. So we're given that the native width is 1164 pixels. Alright, then it says required. We have actually the requirements now. So it says the required width should be 800. And then it gave us the required length. Should be 384. So we need to find the ratio. Alright, so do you notice that we have two width and only one length? Our length is the height. Let me reword that. That is the height. So what you want should always go up on top. It should. But let's say you don't. Let's say you're like, I don't really know what I'm looking for right now. Then that's okay. I'm going to show you a different way to approach this. So we know this is a proportion because we're trying to find the ratio. Ratios, we find them using proportions. So let's just say you start off with native width because that's the first thing you see on the given. That's okay. Native width. So do you notice on the left side we started with native? And on top we're writing width. So another width we have, that's the required width. Height, we don't know the native height, but on the left side it better be native. That's what we're trying to find. So on the left side we have native, top being the width. So on the right side we have required. So what we're looking for now is another requirement. We have the required height. So you see how on the left we have native width over height. On the right we have required width over height. You want things to always match up. So writing it out before you fill out the proportion is super helpful. Our native width is 1164. Our native height we don't know. Our required width is 800. And our required height is 384. Because this is a proportion, we always cross multiply. So x times 800, that's 800x. 1164 times 384, we get 447,456. We're going to divide by 800. And when we do, we get x equals 559.32. So we have to always round down. Even if this was 0.99, we still have to round down so it fits into the picture. So the requirement would be 559 pixels.